Hello, Precalculus student. This video is for chapter 1.5. We are on transformation, the second part of transformation, looking at how we can change a parent function or any function by changing um, the by doing three kinds of transformation called reflection, stretch, and compression, and how it relates to the formula in terms of a function. So if I have an original f of x function and I reflect that function over the y-axis, the new function formula becomes f of negative x, the negative inside. If I reflect over the x-axis, that means up and down, then the new function is negative of f of x because the y would have a negative number, so y become negative y. We can also attain horizontal compression or horizontal stretch by multiplying a number a, which is a constant, inside the function ax. So if a is greater than 1, it is a compression. If a is less than 1, it is a horizontal stretch. Whereas I can do a vertical stretch or compression if a is multiplied outside. So similar to the idea of vertical shift and horizontal shift, whenever it is applied outside, it is vertical. So, but if a is less than 1, greater than 0, then it is a compression. And if a is greater than 1, it is vertical stretch. Okay, so let's look at some example. So someone write a function y equal to f of 2x. How does this function related to the parent function f of x? So we can see that the number 2 is being I'm using it should be this one. So we can see that this is using a multiplying a 2 inside. So if I multiply a number inside, is meaning horizontal. Okay, and the number 2 is greater than 1, so it is horizontal compression. So we can write that this new formula will have the same as the similar shape as the original function, but horizontal compression. Okay, it's not stretching, it's compressing it by a factor of 2. By a factor of 2. Okay. And what about if I have a function that is graph as y equal to f of negative x? So remember, anything negative is inside, is horizontal, so we reflect sideways. We reflect over the y-axis. What about if I have both a negative outside and a number 2 multiply outside? So this means I do the reflect vertically, that means up and down. Reflect over the x-axis. So anything up become down like that. And then the 2 would be vertical stretch. So 2 really means stretch now for vertical. By a factor of 2. Okay. So the third example would be if I give you the parent function and I describe the transformation, write the formula. So y equal to the parent function is x cubed, and I do a vertical stretch, a factor of 4. That means 4 multiply outside x cubed. So that would be the formula. If g of x is 1 over x squared, and we want to reflect it over the x-axis, so reflect this. So originally, it's like that, right? If I want to reflect over the x-axis, that means g of x will become negative of 1 over x squared. And then I do the vertical stretch by 2. Vertical stretch by 2 means this whole thing multiplied by 2. Okay, so it'll be negative 2 over x squared. So that would be the function that would be similar to that. The last thing we want to do is combine the transformation. So we know the stretch and reflection, and then earlier we have the shift up and down. So if we are to like combine them together. If someone give us a formula that is a f of x plus k, what should we do? Should we do the um, shifting first and then the vertical stretch, or should we do vertical stretch and then the shift? So what the general idea is, if we have vertical stretch and stretch and also vertical shift, we always do the vertical stretch and stretch first and then apply the vertical shift. For horizontal, if I have f of bx minus h, so we will do the shift first and then do the horizontal string and shift. Now, but inside, if I have b open parenthesis x minus h, that means the b is there is a x minus h first, then you will do the stretch and the stretch compression by the factor of b first and then shift. Okay, so notice the difference. Vertical and horizontal transformation are independent, so it doesn't matter whether you do horizontal first or vertical first. So let's practice. So here we have, usually we do horizontal first. So we have horizontal minus 1, which is, well, first of all, look at the transformation. If someone want to graph g of x to x minus 1 cube, the parent function, of course, is x cube, right? This is the parent function x cube, and it's supposed to be like that. Right? What kind of transformation will make x cubed become this? Of course, inside we see a minus 1, which is right 1. And then outside is a vertical stretch. So this is step 1. And then we do a vertical stretch. That means the whole thing gets stretched up by 2. So we know x cubed is like this. If you do right 1, so then it would be like this. Stretch up means it's more skinnier, right? Everything like that. Well, I think that it go over this side eventually, but yeah. So this is a square root of negative x plus 2. Usually we would say the parent function is square root x because we have a negative x, a reflection. So we would do, if there is no parenthesis, we do the shift first. So the transformation would be plus 2 is what? Left 2. And then we would do a reflection inside, right? Reflection over the y-axis. So when we sketch it, we would say it would be here first, and then we'll reflect over this. So that means it's like that. Meaning, in the beginning, I do it the left first, and then I'll do this, which is reflect over over the y-axis, like that. So it become this becomes shift over that. So this is the sketch, right? So this is following this notation, f of bx minus h. If there's no parenthesis in front of x minus h, we do the shift first. We do the shift first, which is different for vertical. For vertical, we do straight and strip first and then shift. Let's do 2 more examples. So this is negative x squared plus 2. So they're both vertical, right? So this is vertical up 2. This is a reflection. So we always do the reflection first. So the parent function is x squared. And we'll look at negative, which is a reflect over what? Over x-axis because it's outside. So it's just shift up and down. X-axis is here, so it would be shift up and down. So it would be like this first. So this is x squared. And then this would be negative x squared, right? And then we do up 2. So we shift it and then up 2. So if I aim to sketch it, so I will pretend that it is going like this first and then up 2. So automatically there is a 2 here. Okay, 0, 2 here. The vertex. What about 1 or 1/2 x cubed plus 1? So 1/2 is outside. So and also the parent function is x cubed, right? And this is multiply outside, so it's vertical shift. So we do this first, but it is a vertical, not shift. It's a vertical string or compression by 1/3. So string, no, by 1/2. So because 1/2 is less than 1, so it's string. And then it is vertical shift up, right? Outside is up. So if I sketch it, so it would be vertical string by 1/2 will be like fatter, like shorter, and then up 1. So it would be here, but the whole thing would be like less, be shorter. So this is how you can use transformation by looking at what is being done algebraically to the formula. And then if you know the shape of the parent function, you can actually just graph the new transformed function by using transformation. Anything that is add up inside and outside would be shift left and right or up and down. Anything that multiply would be a stretch or string. And if you have negative, that's a reflection basically. So just need to know these two table, okay, and that is 1.5.